In the final part of this lecture, we'll consider the remainder theorem. The remainder theorem states that if a polynomial f of x is divided by x minus a, the remainder is f of a. You may be able to realise from that the factor theorem is a specific case of the remainder theorem, but the remainder is 0. Let's have a look at the first example then. In example 1, we'll find the remainder when x cubed plus 2x squared minus 1 is divided by 2x plus 1. We'll begin by writing f of x is equal to x cubed plus 2x squared minus 1. And we want to evaluate this at f of minus half. And that's just the value of x, where 2x plus 1 is equal to 0. So substituting in the values, minus a half cubed is going to be minus 1/8, plus 2 times a quarter minus 1. So that's going to be minus 1/8 plus 4 over 8 minus 8 over 8. That will give us minus 5 over 8. In the second example, we'll use simultaneous equations to solve a problem. If you're not comfortable with linear simultaneous equations, you can come back to this part of the lecture after studying lecture 1.6, where we'll cover simultaneous equations in more detail. In the second example, the expression 2x cubed plus x squared plus bx plus 2 is exactly divisible by x plus 2. In other words, x plus 2 is a factor of this polynomial expression. It leaves the remainder of 12 on division by x minus 2. We had to find the values of a and b and factorise the expression. We have f of x is equal to 2x cubed plus x squared plus bx plus 2. We'll start by finding f of negative 2. We know this is going to be equal to 0, so it will be minus 16 plus 4a minus 2b plus 2 is equal to 0. So 4a minus 2b minus 14 is equal to 0. That is 2a minus b minus 7 is equal to 0. And we'll call that equation 1. Then we'll find f of 2. So that's going to equal 16 plus 4a plus 2b plus 2. And we know the expression has a remainder of 12 when it's divided by x minus 2. So this is going to equal to 12. So 4a plus 2b plus 6 is equal to 0. That is 2a plus b plus 3 equals 0. And we'll label that as equation 2. What we have to do then is solve these two equations simultaneously. If we subtract equation 1 from equation 2, we'll get 2b plus 10 is equal to 0. So that implies that b is equal to minus 5. So therefore, a is equal to 1. We can write the function f of x as 2x cubed plus x squared minus 5x plus 2. We know that f of negative 2 is equal to 0, so we can go about a long division again. X into 2x cubed is going to be 2x squared. When we multiply that out, we'll get 2x cubed plus 4x squared. Then we'll have minus 3x squared. x into minus 3x is going to be minus 3x, multiply out minus 3x squared, and minus 6x. Minus 5x minus minus 6x is going to be x. X into x is going to be 1, so that will be x plus 2, and when we subtract we get a 0. So we know we've done this division correctly. Okay, so we can express the function f of x as a product of x plus 2 and 2x squared minus 3x plus 1. And you should be able to see that 2x squared minus 3x plus 1 will factorise to x plus 2, 2x minus 1, and x minus 1. Now have a go at the multiple choice question.